Welcome to Tech Mastery Guru and this comprehensive refresher guide on C language. This video covers interview questions and fundamental concepts of data structures, pointers, embedded systems, algorithms, and practical implementations for C programmers and systems developers commonly asked in interview for embedded system. Let's explore structure versus union in C, focusing on their memory allocation. Structures allocate distinct memory for all members, allowing simultaneous access. Unions, however, optimize memory by allocating space only for the largest member, meaning only one member can hold a value at a time. The volatile keyword is a type qualifier that prevents aggressive compiler optimizations. It's crucial for variables whose values can change unexpectedly, such as memory-mapped peripherals, variables modified by interrupt service routines, and those shared in multi-threaded environments. Understanding static versus extern is key for managing variable scope and linkage. The static keyword limits scope, making variables persist within functions or visible only within a single file. The extern keyword declares external linkage, informing the compiler that a variable or function is defined elsewhere, enabling multi-file access. Pointer qualifiers, specifically the placement of const, drastically change what can be modified. Reading declarations from right to left helps clarify. Const char asterisk p means the data pointed to cannot change, but the pointer itself can be reassigned. Chars const p means the pointer cannot be reassigned, but the data it points to can be modified. Dangling pointers are a common and dangerous pitfall in C, occurring when a pointer references deallocated or out-of-scope memory. Dereferencing them leads to undefined behavior. To prevent this, always set pointers to null after freeing memory and avoid returning pointers to local variables. Function pointers store a function's memory address, enabling flexible programming patterns. They are essential for implementing callbacks, state machines, and dynamic function dispatch. This allows for event handling and polymorphic behavior without object-oriented features. Let's differentiate between microprocessors and microcontrollers. Microprocessors are CPU only, requiring external components like RAM and I/O. Microcontrollers are complete systems on a chip, integrating CPU, memory, and peripherals, ideal for embedded systems and IoT devices. Interrupts and polling represent two distinct approaches to monitoring hardware events. Polling continuously checks status, consuming CPU cycles. Interrupts, on the other hand, are event-driven, signaling the CPU only when needed, which is more efficient and provides faster response times. An interrupt service routine, or ISR, is a special function executed automatically when a hardware interrupt occurs. ISRs must be kept short and fast, avoiding blocking operations like delays or dynamic memory allocation. Always remember to clear the hardware flag to acknowledge the interrupt. The bare metal LED blink is the hello world of embedded programming. This exercise demonstrates direct hardware manipulation through memory-mapped registers, which is the core of embedded programming without an operating system. Key concepts include bit manipulation and infinite loops. Comparing I2C and SPI, both are vital serial communication protocols in embedded systems. I2C uses 2 wires, is slower, and supports multiple devices through addressing. SPI uses 4 wires, is faster, full duplex, and uses separate select lines for each device. A watchdog timer is a critical hardware failsafe that automatically resets a microcontroller if the software hangs or crashes. It functions by requiring the software to periodically kick it. Failure to do so results in a system reset, ensuring reliability. Reading analog sensors involves a systematic 6-step ADC pipeline. From connecting the sensor to an ADC pin and configuring the ADC, to starting the conversion, waiting for completion, reading the digital value, and finally converting it to a physical unit. ADC resolution defines the number of distinct digital steps an analog-to-digital converter uses. A higher resolution, like 12-bit, provides more steps and a smaller step size, leading to a more precise measurement compared to an 8-bit ADC, which has larger steps. Various ADC types offer different trade-offs. Successive approximation ADCs balance speed and resolution. Flash ADCs are ultra-fast but low resolution. Sigma-delta ADCs provide extremely high resolution for precision measurements, though they are inherently slower. Pulse width modulation, or PWM, achieves an analog result from a digital signal by rapidly switching it on and off. The concept of duty cycle is crucial, defining the percentage of time the signal is, quote, on during one period, directly impacting the effective analog value. PWM frequency and duty cycle control different characteristics. Duty cycle, or width, dictates the average power delivered. Frequency, or speed, determines how fast the signal switches. Correct choices prevent issues like LED flicker or motor whining. PWM is versatile in embedded systems. For dimming LEDs, it controls brightness by varying on time, using high frequencies to prevent flicker. In controlling DC motor speed, PWM regulates average voltage efficiently, allowing motor inertia to smooth power pulses. PWM signals are typically generated using a microcontroller's dedicated timer/counter peripheral. This process sets the frequency and duty cycle, triggering output pins high and low. This hardware-driven approach ensures precise timing independently of the CPU. PWM resolution determines the number of distinct duty cycle steps. An 8-bit timer provides 256 steps, while a 10-bit timer offers 1024 steps, allowing for much finer control. Higher resolution is crucial for precise adjustments, such as smooth LED dimming or accurate motor speed control. Finding the kth largest element efficiently can be done using a minute heap. This algorithm takes O(n) log k time and O of k space. It involves maintaining a minute heap of size k, ensuring the heap's root always holds the kth largest element found so far. The fork paradox allows a program to enter both if and else blocks. When fork executes, it creates a new child process. The parent receives the child's process ID, entering one block, while the child receives 0, entering the other, both running independently. Recursion is a programming technique where a function calls itself to solve simpler subproblems. It requires a base case to terminate and a recursive step that calls the function with a modified problem. A classic example is computing factorials. Checking for powers of 2 can be done efficiently with bit manipulation. Numbers that are powers of 2 have exactly one bit set. The trick involves performing a bitwise AND operation between the number and one less than itself. If the result is 0, it's a power of 2. In-place string reversal modifies a string without extra memory allocation. This is typically achieved using a two-pointer technique. Pointers move towards the center of the string, swapping characters at each end until they meet, resulting in oxygen mononitride time and O(n) space complexity. For dynamic memory allocation, malloc allocates uninitialized memory, while calloc allocates and 0 initializes memory. Endianness detection determines byte ordering. Big endian places the MSB at the lowest address, while little endian places the LSB there. Thank you for watching this video. We hope this comprehensive guide has been a valuable refresher on C language keywords, data structures, pointers, embedded systems, and algorithms. Thank you for watching. For more deep dives, insights, and updates, be sure to follow and subscribe to Tech Mastery Guru on your favorite platforms.